Alrighty, we're going to find the area of a parallelogram. As usual, we're going to do it the hard way first, and then afterwards, we'll do it the easy way. Anyway, so the hard way is to use the formula for the area of a parallelogram, which is base times height. And the height, of course, of the parallelogram is how tall it is, and you measure its height along a line that passes through one of the vertices up here and is perpendicular to the base. So it's not like side length times base, it's height. We have to cut through perpendicular. Okay, so what we're going to have to do then is we're going to have to find the height, the distance from here to here, perpendicular to the base. Which means we're going to have to find the equation for the line that makes up the base, an equation for the line that makes up the height, find the point where they intersect, and then the distance between D and E, the point of intersection. And it's a lot of work to get that height. Let's do it. Let's see. So DE. Let's find AB first. So line AB. Look here. Wait a minute. Oh, no, we're going up here for that. Oh, okay. Phew. Off track here. All right. So line AB passes through 0, 0 and has a slope of 2/5, right? Because it goes over 5 and up 2. So that one actually. The slope is 2/5, and the equation is a pretty simple one. Y equals 2/5 x. We don't have to do anything fancy because the y-intercept is 0. All right, now for the slope of AB, it's going to be that negative reciprocal slope. So it's going to be negative 5/2. So just flip it upside down and change the sign. We'll go back here. That line passes through the point 1, 4. So our equation is y equals m x minus h plus k, where m is the slope and hk is a point that it goes through, in this case, the point 1, 4. 1, 4. So let's see. Y equals negative 5/2 x minus 1 plus 4. Let's see, y equals negative 5/2 x minus, I need a calculator here. Let's get the calculator out. Alright, so it's going to be plus 5/2 plus 4. So let's see, clear. 5/2 plus 4 is 6.5. Which is 13/2. So 13/2. So that's 5/2 times 1 plus an additional 4 there. 13/2. Okay. Now that we've got those two equations, let's find the place where they intersect by taking this expression here next, setting it equal to this expression, and solving for x. So let's see. We'll have 2/5 x equals negative 5/2 x minus 13/2. So the 2/5 x comes from our first equation, and the negative 5/2 x minus 13/2 comes from, except this should be plus 13/2. That's a typo over there, so let's fix that. Comes from the second equation. So let's see, we'll add, add 5/2 x to each side. So 2, Alexa stop, 2/5 plus 5/2 is 2 9/10, which is 29/10. So we got 29/10 x equals 13/2. So we're going to divide 13/2 by 29/10. 13/2 divided by 29/10 is 2 7/29, or 65/29. Let's just check and see if that seems reasonable. If we look down here, it is 2, a little bit more than 2, and that was what our 2 7/29, so yeah, like a little bit more than 2. That seems reasonable. Okay, so that's our x coordinate. Let's find our y coordinate. So now that we solve for x, we know the x-coordinate. We plug it back into one of these equations to find our y-coordinate. And I think the easy one would be y times is 2/5 times x, which is 65 over 29. So take that and multiply it by 2/5 times 2/5 gives us 26 over 29. 26 over 29, which is a little bit less than 1. If you look here, it does look like our y-coordinate is a little bit less than 1. So again, that seems reasonable. Okay. So we now have the location of point D, or point E, sorry, which is 65 29ths, comma, 26 29ths. And that's the location of point E right here. Now we're going to find the length DE. DE is equal to, we'll use our distance formula, the distance from 1, 4 to 65 over 29, comma 26 over 29. So let's see, that's 1 minus 65 over 29 squared plus 4 minus 26 over 29 squared. Okay. Now let's work out this inside part here. Let's see. 1 minus 65 over 29 squared plus 4 minus 26 over 29 squared is 11 and 5/29. Let's see. 324 29ths over 29. Now let's see, I think, yeah, that's 8 square root of 18. That's 18 over square root of 29. But we're not going to worry about that right now. We're just going to leave it as a square root. So that's DE. For AB, all right, let's use Pythagorean theorem to find the distance from A to B. That's the base. So we have the height. Now we want to find the base. And that's just, yeah, Pythagorean theorem. That's a lot easier. 5 squared plus 2 squared is c squared. That's 25 plus 4 is c squared. So we end up with 29 is c squared, or c is the square root of 29. And so that's the, since we're going over 5 and up 2. And now to find the area, it's just base times height. So area, base times height. That is our base. That's square root of 29. And our area, here we go, was 324 over 29 with the square root of that. So actually, this works out to 18 over square root of 29. So I take the square root of 324, I just get 18. You can break the square root apart if it's a fraction, numerator and denominator separately. So that would be square root of 324 over square root of 29, but square root of 324 is just 18. So 18 over square root of 29. And normally I would not want to leave a fraction like that with a square root in the denominator, but because we come down here and I see the height, the square root of 29 cancels with this square root of 29, and our area just ends up being 18 units squared. So again, that's the long way. First thing we had to do, all the way up here, we had to find an equation for the, oh, I wrote these wrong, by the way. This is the equation for AB. Okay, I had to find an equation for AB, that's the base. And then an equation for DE, that's the height. Okay. Then we had to move in here and set the two x expression portions of the equation equal to each other. This came from AB, this came from DE. We set them equal to each other. We solve for x. That gives us the x coordinate for the point of intersection. Then plug that back into one of the equations. Doesn't matter which one. Both of them if you want to be extra certain. And then evaluate to find your y coordinate. So this is the point of intersection. There's the x coordinate. There's the y coordinate for point E. And then we had to find the distance from D to E. That's the height. It helps everything in your diagram here. That's the height. Right. And once we find the distance from D to E, that's the height of the parallelogram. Then we had to find the length of the base of the parallelogram. It was a little bit easier because we could use Pythagorean theorem there. And then base times height equals area. That took a long time. The easy way, here's the easy way, which if you can do it, you'd want to do it this way, is to take your parallelogram, and I just redrew it over a little bit on the coordinate plane because we don't actually need any of the coordinates to do this. I'm just going to box it in like so. Like so. Okay. And let's see, I'll go over here, and so I have a large rectangle here, 1, 2, 3, 4, 5, 6 by 1, 2, 3, 4, 5, 6, so a 6 by 6 rectangle or a square, and the area of that is 36 units squared. And then let's see, we'll take away, so 36. Got 2 here and 2 here, so minus 4. And then that's going to be 32. And here, this triangle here is 1, 2, 3, 4. That's another 2 units. And this triangle here is a 4 by 1, so that's another 2 units. So I'll take away 4 more. Let's see, we're down to 28 now. This triangle is 1, 2, 3, 4, 5 by 2. So that's 5 square units there. And this one down here is also 5 by 2. So that's another 5 square units. So we'll just take away another 10. Gives us 18 units squared. So much, much faster. That took like just a few seconds compared to the other one. And then basically the gist of this method is just going to box everything in to make a big rectangle that I can easily find the area of, and then cut away these smaller rectangles and right triangles until we get down to just the shape that we want to find the area of. So much, much easier. But it is good. We need to know how to do it the other way in case we have to work.